In parallel, I could make this one so the picture's going to look like this because it's a simple parallel. So what we have is we have a 3 ohm, a 5 ohm, and a 6 ohm resistor are connected in parallel. Now, those would be connected in parallel to a 30-volt battery. Again, the question is what's the current through each resistor and the voltage drop across each resistor. So I'm going to put these on my generic circuit that I have here. So I'm going to have my V123 is going to equal 30 volts. And then I can call that R1 equals 3 ohms. R2 equals 5 ohms. And R3 equals 6 ohms. Now, in solving for the equivalent resistance, it's a little bit tougher than it is in series, because in series you just added them up. But when you're figuring out the equivalent resistance in parallel, you have to add up the reciprocals. So 1 over R123 is going to equal 1 over R1 plus 1 over R2 plus 1 over R3. And by adding up the reciprocals, what you will always get is you will get a smaller resistance. Remember I told you that in parallel, because every time you create another branch in the parallel circuit, you create another path for the electrons to move. And that actually lowers the total resistance of the circuit. If the only way that this charge could get around would be to go through that way, well, you'd have 5 ohms of resistance, and it would limit how much current leaves your power source. But because I have options, the charge doesn't have to go that way. It can go around that way, or it can go that way. Because there are other options, it lowers the equivalent resistance of the circuit. The circuit doesn't know, like the battery cannot sense that there are 3 resistors out there. What the battery can sense is what the equivalent resistance is, what that number is. And that determines how much current leaves the battery. So that's all that it's going to sense. It has no idea. For all it knows is whatever this value is for R123, for all of the battery knows there's just one resistor out there with that value. Right? So in solving this, like I said, the math's a little bit harder because you have to add up fractions. So you can have 1 over 3 ohms plus 1 over 5 ohms plus 1 over 6 ohms. So I'm adding fractions with different denominators. So what would be the least common denominator of those? 30. So 1 over R123 is going to equal, with the least common denominator of 30, to go from 3 to 30, what do I multiply top and bottom by? 10. So there's the first one. Plus, to go from 5 to 30, top and bottom by 6. And to go 6 to 30, top and bottom by 5. All right. And now I've seen people make the mistake of, if I add this up, that's going to be 21 over 30. And I've seen people make the mistake that they'll just write that as their equivalent resistance, 21 over 30. But remember that that's what 1 over R123 is. We want R123, so we have to flip over that, and we're going to say that R123 is going to be 30 ohms divided by 21. So I know it's going to be more than 1, so what's that answer be? What's 30 divided by 21? 1.43. All right, so now that I know the equivalent resistance, I can figure out the total current, the current that leaves the battery before it gets broken up when it goes through the parallel section of the circuit. So that would be something that I could solve next using Ohm's law. It's going to be V123 divided by R123. So that's going to be 30 volts divided by 1.43 ohms. And what is the current that leaves the battery here? 21.0? 21.0 amps. And so that means that 21.0 leaves the battery, and then when it gets to here, some of that 21 goes that way, some goes that way, and some goes that way. So we now need to figure out how much goes through each of the resistors. Well, one thing that I know in a simple series is no matter what charge goes around the circuit, it's only going to go through one of our three resistors. It's not going to like go through here and then come around here and go through there. It's either going to go through that one, or it's going to go through that one, or it's going to go through that one. So it basically has to lose all of its voltage in one step, rather than in series where it had to drop in 3 steps. Whatever energy it had, whatever voltage it had here, it has to lose it by the time it gets there. So I know, without doing any math, conceptually, I should know that if I know what V123 is in parallel, then I know what V1 is, I know what V2 is, I know what V3 is, and they all equal 30 volts. So I didn't have to do any math for that, but you need to be aware of that. So, you know, when I ask the questions, I might say, well, I might not say, well, what's the voltage V123? I might say, what's the voltage through the 5 ohm resistor? And knowing what the voltage is on the battery, I will know what the voltage is that goes through the 5 ohm resistor. So now, once I have that, the only thing left to solve are the 3 currents. So I1 is going to be V1 divided by R1. I2 is going to be V2 divided by R2. And I3, I'll do it over here, is going to be V3 divided by R3. So in all 3 of these, so I'm doing them all at the same time, in all 3 of these, the voltage is the same. So remember, in series, the current was the same in all 3 when I was solving for the 3 voltage drops. In this one, the voltage is the same. So I'm going to have 30 volts, 30 volts, and 30 volts. And the only thing that's different are the 3 resistors. So R1 is 3 ohms, R2 is 5, and R3 is 6. Pretty convenient numbers because I'm going to get whole numbers for all of them. 30 divided by 3 is 10, so 10 amps. 30 divided by 5 is 6 amps. And 30 divided by 6 is 5 amps. And if I add, and I can check that, I can check those numbers, because if I add up 10 plus 6 and 5, they should add up to my total current. All right, so that's how you do that. Now, of course, I could ask what's the power through one of them, which is just V times I.